Okay, number 21 is 2y. Oops, don't want green. Let me erase that. 2y dy dx equals x over the square root of x squared minus 16. All right, that's an equal sign, equals. And our initial condition is y of 5 is equal to 2. And the problem says, let's see, the directions say find explicit particular solutions of the initial value problems. So this is initial value problem because we have a differential equation and we have the initial condition. And it says find explicit, so we're focusing on explicit, and particular, so that means we're going to use the initial condition to find our constant c. So remember, the goal is to separate the variables, right? And we want it to look like f of y dy equals, I don't know, g of x dx. And again, I can move, this can be on the right and this one can be on the left. As long as you have a function of one of the variables and a function of the other variables. And your dy and your dx are in the numerator. So because I know I want them to be in the numerator, I'm going to multiply both sides by dx. I mean, you could divide by dy to both sides, but dy is already in the numerator, so we don't want to change that. So if I multiply both sides by dx, we get, well, this is nice because that's gone, we get 2y dy equals x over the square root of x squared minus 16 times dx. And so again, the goal is to try to separate our variables. And this actually, we're pretty much done because for separating the variables part, because we have a function, right, f of y dy, and we have a g of x dx. So we can start integrating. So let me just pick a different color here. So I can integrate now, but I'm going to go ahead and rewrite. I can factor, right, or using the constant multiple rule, I can take out the 2, integral y dy equals, and I'll just write integral of x over this radical function dx. Okay, so the left-hand side of the equation is a very easy integral, right? It's 2 times, using the power rule, right, y squared over 2. If you want to add a constant, well, you should add a constant, and I'm going to call it c sub 1. In this integral, we're going to use substitution, the u substitution. So maybe, let me just get a different color here. So I'm going to use u substitution on the right-hand side. So I'm just going to hang on to this part and do this part. So if we focus on this integral, I'm going to let u be x squared minus 16. So du is 2x dx, right? And plus a constant of 0, because the derivative of negative 16 is 0, but we don't have to write that. Now, our goal is we want to write, this expression, or this integral, in terms of du. So here I have x dx, and here I have an x dx. So I can, let's see, let's get, I don't know, purple or pink. So I have this part, right? It's right here. So if I solve for x dx, I get x dx, right, equals half of du. So I can replace, right, my x dx with this expression. And so what else do we have? And then we have the 1 over, okay, that radical function. Let me make this a little smaller so you can see. Okay, so we have, okay, the same integral, well, that's just going to be 1. So we have y squared plus c1, and that's going to equal, so the integral of x dx, well, that's 1/2 times du And then we have our 1 over the square root of, and then u, because that's what I let u be, x squared minus 16. So if I rewrite this just a little bit nicer, I'm gonna take out the half because I'm allowed, and this is really 1 over, okay, the square root of u du. Again, I want my du's at the very end. Okay. Okay, so we're done integrating the left-hand side, right? This guy is done, so I want to focus on this integral. So let's see. Well, let's keep writing this so we won't forget it. So recall, let me choose a different color here. So I want to rewrite this integral, or this function of u. I know that from algebra, so 1 over the square root of u is the same thing as u to the 1/2, right, power. And we can rewrite that as u to the negative 1/2. So that's what I'm going to replace this by, because that's what it's equal to. So we have the integral of u to the negative 1/2 du. And we have a half, and then this guy, this is just going to be, well, we could put brackets. That's going to be u to the negative 1/2 plus 1 over negative 1/2 plus 1 plus our constant, second constant of integration. And let's see, let's simplify this a little bit. Let's see, 1/2, and then we have u to the 1/2, right? 1 minus a half divided by a half. Let's see, let's keep the brackets. And this is C2. And let's see, okay, so again, y2 plus c1. Let me move this up. So we have, okay, this is really 1/2 times, right, this is really times 2, u to the 1/2 plus c2. And okay, let's just do this, equals, if I multiply, right, if I distribute that guy, I get u to the 1/2 plus 1/2 c2. And then we have, okay, y squared plus c1 equals, but what was my u? My u was x squared minus 16 plus, and I'm going to just go ahead and write c, right, because I can, again, bring this c1, and so this, it's c2, whoops, right, the c1 I'm subtracting from here, and again, it's just going to be some constant. Okay, so let's rewrite this. And I want a particular solution. So from my initial conditions, what was it? We had y of 5 is equal to 2. So that's 2 squared equals 5 squared minus 16. Right, so here I'm using y of 5 equals 2. And let's move this up. And so if we just simplify this, right, 4 equals, and let's see, that's 25 minus 16, which is 9, plus c, and then of course 4 equals 3 plus c, so c is 1. So now let's write our particular solution. And our particular solution is y squared is the, let's see, whoops, x squared minus 16, right, the square root of that, or they write it as one, that expression to the half, plus our c, and our c is 1 in this case. So it's a particular solution, right, because we don't have here, our c is fixed. There's one particular solution with that c, and this solution, right, y is defined implicitly. Okay, so notice that the question asked for, it said find explicit particular solutions of the initial value problem, and we found a solution, right? y is defined implicitly, but they wanted an explicit particular solution. This is fine because it is, I mean, y is defined implicitly. If you wanted to find an explicit one, let me move this up, right? You can take, okay, so here is our solution. If I wanted to solve for y, I could take the square root of both sides, right? Or it's the same thing as raising both sides to the 1/2. And so I would just get y because half of 2 is 1. And then I would be, I guess if you wanted to write it like this, the square root of the square root of x squared minus 16 plus 1. And again, when you take the square root of both sides, which we did, of an equation, right, you have to write, let me write here, the plus or minus. So you either have y is equal to plus, whatever this expression is given in x, or a y equals minus this expression, right? So the positive solution, or the positive value, is going to be a curve above, right, the x-axis, and the negative value is going to be, because it's an output, it's going to be below the x-axis. But the book writes it like this, and this is fine. Again, because it's defined implicitly, you can't really do anything else.